And by the way, all right. I remember correctly from the survey you guys filled out, quite a few of you haven't been in math in a while. Blah 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 blah. There you go. What's really weird for math students is you guys don't necessarily know what it feels like to truly understand an idea. That leads to your inability to gauge how far you are from understanding. Yes? So even if you're like, I don't even know what to ask this guy, so I'm just not going to ask. No, don't do that. Come to my office. Come in and just go, I don't even know what to ask you, man. Just nothing makes sense. We'll do a specific problem. I'll see how much you can do. I'll see what's in your way. Very often it's just one or two little misunderstandings, one or two little things you're looking at wrong, and all of a sudden you can do all these problems, the next 60 problems or whatever. You guys with me? That has happened so often. But if you don't do that, I can't help. Right? So again, I'm in the classroom roughly 7:30 until 8. If I'm not in here at 7:30, I'm definitely in my office. And if you get here before 7:30, I'm in my office. I try to get here about 7 at the latest, so I can kind of like prep and stuff. But you guys can come over and just say, hey man, I see you there. Can I ask you something? No big deal. You guys with me? So a big part of this is up to you. It's just how much do you want to reach out for help. I can't do that for you. Okay. So anything before we jump into where we left off last time? Anything? Everybody got their tests back? I think somebody just came in. Everybody got their tests back last time or this time? Blah, blah, blah. Okay. Nothing. Okay. All right. So let's do this. Let me first do this. I always forget to do this. A little ambiance. I didn't bring my little candles. I'm sorry. So, okay, now I'm going to bring it back up. House lights. There we go. Space lights off. All right. First thing I want to do. Last time we started talking about transformations. And let me, before I talk about some semi-new stuff, let me go over what we know so far. If I have a function, yes, and it does this, how would that shift? Say again. 1 to the left. Kick ass. And again, students balk at that at first because you see it says freaking +1, Jeff. Why are you going like back 1? Because now every input can be 1 smaller than they used to be. Because the first thing I'm doing is giving 1 to them. That's why the whole thing goes back 1, because they can all be 1 smaller than they used to be. So this would be left 1. Whatever the function looked like, be it a square root, be it an absolute, blah, 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 this would be left 1. So if I had a parabola, it would shift left 1. Morning. What does this do? Now, real quick, let me see if you guys. All right. I really want you to understand why these are looked at differently. Okay. Do y'all agree with me that that 1 is with the x? Do y'all agree with me? Let me see. Let me write this down. Let's investigate this. Is that 2 with the x? No. Is that 2 with the y? No. It's not with the y, is it? All right, now listen. What I'm about to do, I'm going to explain this 2 different ways. I'm going to tell you, the way I told you last time was, whatever this looks like, all the outputs will now go down by 2. So it literally just makes it go down 2. But then as a student, I don't blame you if you're like, okay, math boy, that says +1. You said to go back 1, blah, 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 and here's his -2. Why wouldn't I go up 2? I don't blame you. I'm not saying you sound like that. That was terrible. Could I move that 2 with the y? Could I make the 2 go over with the y? Could I solve for the square root of x? Could I get the 2 on the other? How do I get the 2 on the other side? Add 2. Is that 2 with the y now? So when it's with the variable, it does the opposite of what it looks like. In this problem, all my inputs can be 1 smaller than they used to be because I add 1 to them. I need this to make sense. What is this function, whatever this thing is, what's it do first? When I plug a number in, what's it do first? So for example, this could be this. When I plug a number in, if you plug in a 3, what's the very first thing you do? Very first thing you do if you plug a 3 in. So what's the very first thing you do? Very, very specific. I add 1, yes? So before that was there, what would you plug in to get a 4 out? What positive number would you plug in for x to get a 4 out? 3 squared is 9. 2. 2 squared is 4, yes? Well, now what number do you plug in for x to get a 4 out? 3 plus 1 is 4 squared is 16. What number do I plug in now to get a 4 out? 1. I need you. If I plug a 2 in, I get 4, correct? If I plug a 1 in, I get 4 now, yes? So whatever I used to need can now be 1 less than it used to be because the first thing I do to it is I give it 1. That's why I go back 1. That can only happen. So now look at my outputs on this one. My outputs. My outputs, yes? You can just look at this. So if I plug a 4 in, what's my output? 2. Now if I plug a 4 in, let me see if you guys are cool with this. Now if I plug a 4 in, what does y have to be? I know the output's still 2, correct? If I plug a 4 in, my output's supposed to be 2. So what does y have to be? 0. Cool. I love it. Let's see. Let's see what the hell I'm talking about. So if I have this, if I plug a 4 in, y is 2, yes? If I have this, if I plug a 4 in, y plus 2 must be the square root of 4. Y plus 2 must be 2. What must y be? 0. 2 less than it used to have to be. Because what's the first thing I'm doing to y now? Adding 2. Should you ever add the dumb 2 over? No. This is the worst way to look at this, but I want to look at it like this for just a moment because if it's in with the variable, it does the opposite of what it looks like. And if it's with the x, it's left and right. If it could be put over with the y, it's up and down. I guess. Now, the right way to look at a number outside like this, the best way to look at that is simply whatever those outputs were, they're now 2 less. Yes? So it will go down 2. But I don't blame students for saying, man, you just said if it was a plus 1 inside, we go back. Why do we do the opposite in one case and not the other? Hopefully, now it makes a little more sense. If it's with the letter, you do the opposite. So I can write this like this. That looks like it's adding 2 to y, so I'm actually going to go down. Because now all my outputs can be 2 less than they used to be. If I have this, that's in with the x, so it will go back 1. It will go left 1. Because now all my inputs can be 1 less than they used to. Let me stop for a minute. A really good question right now that I'm almost certain is on somebody's brain is, the shit are we doing this? Does anybody have that question? You're probably you're like, dude, that's every day I come here and I think that to myself. The general answer is because you need this shit for whatever STEM thing you want to do. The more specific answer is, in this case, how do I graph something that I don't know what it looks like? Some of you guys know what this looks like, yes? Well, let's say we don't. Does anyone not know what this looks like if you graph it? Anybody willing to be honest? Okay, I love it. We got one brave person. What do I have to do if I have to graph something by hand and I don't know what it looks like? What do I have to do?
Plug stuff in.
Plug stuff in. If I can create points for myself. Is that hard? No. Would you rather not have to do that?
Yes.
Shit, yes. So, if I don't know what something looks like, I always put in, to start with, 5 points. Some negatives, 0, some positives. That might not be enough, depending on how funky the function is, but that's a good starting place. If I have no idea what this function looks like, I have to know what it does with positive numbers, I have to know what it does with negative numbers, and I have to know what it does with 0. Does that make sense? I might need more just to kind of fill it in, because if it's a crazy ass function, I'm gonna have to plug some more things so I can see what the hell it's doing, but this is a good starting place. And this is not a crazy function, so it doesn't need much. No, don't start singing. What happens when you plug a -2 in? What do you get out? Absolute value, -2 is 2. That's crazy. So what about when you plug a -1 in? 0? 1? 1. 2? 2. Good. So absolute values, they just make things positive if they aren't already. They don't change the sign always. I always get somebody tell me when you plug a 1 in, you get -1. No, that doesn't make any sense. Absolute value is positive or 0. Go ahead and plot those points, Elway. Somebody brought up a really good point earlier. Dear God, if I was a student in this class, I would say, Jeff, get some freaking graph paper. Because your shit's weird to look at. So if you're anywhere near as not well at drawing as I am, consider getting some graph paper. I actually have some up here, so anyone wants to borrow some, but I don't have like enough for everybody forever. I am just a teacher. I could model what I'm saying and use graph paper, but for some reason I won't. So, I really want to make this really clear. I'm going to say this several times. One of the most important jobs of this class is to put you through the graphing gauntlet. You're going to graph the shit out of so many things. So when the problem says graph this, I need to see scale, I need to see work, I need to see points. Don't just go back and bleh. There you go, Joe. No, it's not the point. In calculus, you're going to make quick, rough sketches just to have like a visual anchor to do a problem, and the more you go through this gauntlet, the easier those are going to be, and then you can focus on calculus. If you're not going to take calculus, great. You have to do it for me anyway. So see, 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. Now, if you're not careful, you might make this into like a parabola, but what's the power on the x? So it can't be curved. It's the first power that's linear. So it's like it's a line that says, oh shit, it can't be negative. Ah! Yes? It's just y equals x, but when it gets to this, it's like, I can't be negative. I got to turn. Can we stop for a minute? Yes?
Should we always include x and y?
Oh, not necessarily, but
Okay. Do you want us to number the?
Yes.
Okay.
You don't have to number every one, but you have to do enough so I can see the scales.
Yeah, okay.
Yeah. Okay, I like it. And again, I don't do that because it's busy work. I do that because I want to catch if you're making wrong assumptions or if you're doing something that leads to wrong graphs, if you don't show me the scale you're using, I can't catch that. Okay, are we all good? Is that all right? So now, that's what this book calls, it's in our toolkit. We all have to know these shapes, yes? We haven't talked about logs yet, but we'll figure out why the log is wrong. It's the only one that's wrong in the shirt, and I'm kind of happy about that, to be honest. Okay, so we all have to know what x squared looks like, absolute value, square root. We have to know what those shapes are. So here's what this does for me. I know this shape now. I don't have to use 5 points. What I normally use are these 3. Those are my anchor points. I call these my anchor points. So now if I'm given a problem like this, I don't have to make a whole XY table. I can graph what I call the base function and then apply the transformations. Can somebody help me figure out what the transformations are? Yes, and you said it the right order. You do order of operations, PEMDAS. So you would do right one first. In this specific example, it doesn't matter, but in general it matters. Right 1, down 3. Right 1, it's inside with the x, so I did the opposite of what it looks like. And then whatever outputs those are, they go 3 down, they go 3 less. So the whole thing is going to shift down. This idea of shifting, transforming functions is huge. It goes beyond just, ooh, now we're able to do it by hand a little quicker. But that's the immediate thing that we can see. So what I do is I graph 0, 0, 1, 1, negative 1, 1, and then I connect that with dotted lines because that's not the answer. I call this my base function. That's the function without any transformations, just the absolute value of x. So now we all know it looks like a v. I need to give myself points so I can move them around. How does each point move? How does each point move? Right 1, down 3. Right 1, down 1, 2, 3. Right 1, down 1, 2, 3. And then there you go. Yes, sir.
I saw in the textbook that it showed arrows going from one function to the next function.
You don't have to do that.
Okay.
If you show me this, do you see how I can see the little counting stuff? That's all I need. Otherwise it gets too busy and it's hard to tell what your answer is.
Okay.
Yeah. You could do several iterations. You could apply one transform at a time. You could use colored pencils, right? Me, I would never, because I'm an idiot. I wouldn't do something that makes so much sense, right? But I love my students. You don't have to. You're not going to get bonus credit. But if you want to use colored pencils in these, little tears, the joy come out for you. That's about it. You don't get any bonus points. You get little tears. How we doing? How do I check this, by the way? By hand, how do I check this? Not in the calculator.
Click stuff in.
What point, what's this point right there?
1.
What point is this?
Oh, 2, negative 2.
2, negative 2. What does that mean has to happen? When the input is 2, the output better be
Negative 2.
Let's see. When I put a 2 in, 2 minus 1 is 1, absolute value 1 is 1, minus 3 is negative 2, kick ass. Do you see that? You can always check your work. I know you could put it in your calculator. Ooh, I don't give a shit. You can check it very much quicker by hand, to be honest. It'll take a while to get it in the calculator, get the window right. Screw all that shit. Just plug the point in.
Is it just always 1 point?
I mean, it's possible that you got lucky and got that 1 point right, even though your graph sucks. But if you got 1 point right, the likelihood is the whole thing is good. If you have more time, check more points. Yeah. But if you check 1 point and it comes out right, now there's like a 99% chance you're right. Just to make up a probability. How you guys feeling? You guys alright? Compared to some stuff, This ain't that bad.
How would you check it again? You said you
Oh,
put it
pick a point that your new graph goes through.
Okay,
And what does it mean for a graph to go through a point? What does it mean?
that it's like on the graph.
True, but what's it mean about the function it came from? That input output have to be true.
Okay.
So what we did was we saw the point 2, -2, input 2, output -2. So I inputted 2,
Okay.
and sure enough, outputted the -2. That point works.
Okay.
I could still be wrong, but the likelihood is so low that I happen to get 1 point right. More than likely, my whole graph is good. Alright, I love you guys. Isn't it good to know how the shit to check yourself as you go through? Yeah, this stuff's weird, man. Give me a way to check myself. Now, what sucks is if you plug it in, you make an algebra mistake. So be careful. Okay. Let's talk about some different kinds of transforms. Because now we have this means up or down, yeah, there, Jeff, left or right by h steps. This means down or up by h steps. Do you see what I mean? Down, Jeff, you did it exactly backwards. I love you, Jeff. Up or down, left or right, beautiful, that works. So it's left or right by h steps, up or down by h steps. If it's in with the x, left and right, because x is freaking left and right. If it's outside, I could put it with the y, so it's up and down, because y is up and down. That's almost too nice to believe. It has to be, because graphs are intimately connected to their functions. So I should expect to see a lot of information about the graph from the function. So what about, okay. What about if I have something like this? What do you got, Jeff? I don't know, Jeff. Let's do, yeah. You guys, that is 2 times the square root of x. That's a coefficient of 2, yes. I wouldn't put it as a root because I don't have the right to. Do it again. In which way? Is that 2 inside with the x?
No.
So which direction is it going to stretch or shrink? If it's up or down. I love it. So it's either going to be I'm going to stretch the function because I'm doubling the output. So right there I just answered the question. Whatever the outputs were before I had the 2 there, they're all going to be twice as big now. Yes? So if the output was 1, the output's now going to be 2. So I literally just double. So what's a square root function look like? Let's remember this. Here, don't take me out, chair. What did I do to you? What does this function look like, the base function? What's the square root of 0?
0.
That's insane. What's the square root of 1? What's the square root of 4?
2.
There you go. That's what. Those are my 3 anchor points. So now how do I do this? What's double 0?
0.
Holy shit. What's double 1?
2.
Holy shit. What's double 2?
4.
Holy shit. So now the whole thing is just stretched up. Why is it stretched up? Because the 2 is not in with the x. It's outside. Do you guys see that? If it's inside with the x, left or right. If it's not inside with the x, up or down. Okay. All right, math boy. What about if I had something inside? Is it okay if I use Roman numerals now? I think so. So everybody agree those are completely different functions? Not completely different, but they are different functions, yes. They have the same base graph, but very different things happen now. Who can tell me what they think happens? It's not gonna be a shift, because this is a multiplier. It's not gonna move every point left or right. It's gonna either stretch it, and I'm doing it, why am I doing it this way? Stretch it or compress it. Why is it left and right? Because the 2 is in with the x. So it's either gonna, like an accordion, it's either gonna stretch it or it's gonna smoosh it. Yes? So what the shit is it gonna do? Why compress? It's in with the x, so it does the opposite of what it looks like. Real quick. In this function, what do I have to plug in to get a 2 out? We said this earlier. What do I have to plug in to get a 2 out? 4. Is everybody with me? What do I have to plug in here to get a 2 out? 2! Half what I used to. That's why it's going to compress by a factor of 2. So what the shit does that mean, Jeff? I don't know. Let's see. So let me graph the base function. There's the base function. Every input now is cut in half. So for example, isn't there an input of 4 that goes here? Cut that input in half. So now what input goes here? 2 goes there. So now I'm going to cut this in half. 4, yes? 4, 3, 2, 1. Or, no, stop. Cut this in half. So at 2 now, so it used to be 4 that went here. Cut that in half, now 2 goes here. At 1, the output was 1. Now what input gives me an output of 1?
Half.
1/2. I just cut every input in half. All the outputs stay the same. Why are all the outputs staying the same? Because the dumb 2 is in with the x. The outputs don't change. Sorry, the inputs don't change. So if I have an input of 1 that takes me to an output of 1, I cut that in half, bam! So now my function looks like this. So it has smooshed. Can you imagine taking a square root and just smushing it? What's going to happen? Isn't it going to like buckle up? If you take gum and you smush it, doesn't it go? So if you smush this, it's going to go. Yes? Okay, maybe? Maybe. It's for you, Jeff. Does anyone notice this actually looks like I stretched it up? Does anyone notice that? Listen, you don't have to. You never have to look at it the way I'm about to show you. In fact, I wouldn't. Can somebody break this up for me? Note, never do this. Square root of 2x, isn't that the square root of 2 times the square root of x? Isn't this now like this one, just worse? What did I do to all the outputs? Did I double them here? What do I do to all the outputs now? I multiply all the outputs by the square root of 2. Whatever this output was, if I multiply by the square root of 2, I go there. Do you have to understand anything I just said? No, it's okay. Just to point out why it looks like I stretched it up, because you can actually factor it. Now, is the square root of 2 in with the x now, the way I wrote it? Is it inside? Nope, it's outside. That's up and down, ain't it? But don't do that shit. I just want to show that to you. That's why it looks like it's a stretch up, because I could write it as if it was a stretcher. I don't want to do square root of 2. I don't want it. Whatever, Jeff. Okay. All right. So a multiplier is going to stretch it or compress it. Stretch it or compress it. Based on if it's inside or outside. Okay. Last thing. Reflections. What happens here? Is it inside with the x? The new thing? No, it's outside. So whatever's going to happen is going to happen in what direction? Up or down, right? Is everybody with me? Okay. It's a bad example. We'll do a different one next. What's an absolute value look like? Can you guys motion in the air for me? What's an absolute value look like? Yes, thank you. Like this. Yes. Like this. You're like, what do you want from me? Either way works. So V, yes? So, what does this do? Whatever the outputs were, if I had an output of 1, what output will I have now? -1. So it just takes all the outputs, multiplies them by negative. So effectively, all I'm going to do is reflect the graph around the x-axis. So let's see. If I have the base graph, 0, 0, 1, 1, -1, 1. Here's my base graph. I literally just reflect. Like this is a mirror. So this is on the mirror, it stays, yes? Reflect. Reflect. Don't do it. No, shut. And then I can draw a nice solid line because that's my answer. Yes, sir.
If the negative was in with the x, would it flip along the y-axis?
Let's take a look. Now real quick, this is kind of dumb
Yeah,
because if I reflect this around the y-axis, it's the same thing.
right.
So let me do this one. Is everybody semi-cool with this?
Mm-hmm.
Do you see how if I said did it flip up or down or left and right, you would say down. It flipped down, didn't it? Why did it flip down? Because the negative's on the outside. It's not in with the x, so it's not left and right. It's up and down. What kind of reflection will this be? Left and right or up and down?
Left and right.
Because x is left and right, and it's inside with the x, yes? What did I, give me, for the base function, give me a number I could not use considering I want to be able to graph this on a real plane.
-1.
I couldn't use -1, correct? Can I use -1 as an input now? Because the first thing I do to it is change its sign and multiply by negative, right? So all the inputs that used to work, the negative of those now work. So it is a reflection. So let's see what this means. The base function is this. Holy shit, Jeff, what awesome scale. 0, 0, 1, 1, 4, 2. But now, this reflects along the y-axis. 1 goes to 1 before, but now -1 goes to 1. This reflects around the y-axis. This reflects around the y-axis. It's a reflection, you guys with me? When you look in the mirror in your bathroom, how far away is that other person that you can't trust? When you turn around, they're just they looking at you. Do you know that? No. When you see that person in the mirror, how far away are they from the mirror? The same distance you are. Because that mirror is flat. If you have a curved, then you get the funhouse thing going on and all kinds of weird shit happens. Objects in the mirror are closer than they appear, right? In your car, because it's curved. So you can see a broader range of things, but then it doesn't tell you reality. So my mirror in this case is the y-axis, so that this has a reflection, this has a reflection, there is the new graph. Yes?
So how did you return negative x into that?
No. Okay. I didn't. This is the problem. This is the base function. I just wrote it there to have a discussion about what used to happen, what happens now. So the first step on any transformation problem is to do a dotted base function. What do I mean by that? Take all the transformations out, just the dotted base function. You have to memorize those.
So right now we're calling the base.
Yeah, so I graphed the base function as a dotted line.
Okay.
And this now is that, which is why I made it solid, because that's the answer. And I want Jeff to know what the hell the answer is. So when he grades my stuff, he doesn't go insane. Okay. By the way, I don't believe I have to say this, but don't put like 7 different graphs on one graph. I always get somebody, A, B, C, D, D, don't you? No. Freaking spaghetti looking freaking graph. No, don't do that to me. Okay.
What if it's one of those things where it asks you all to on the same graph, like where it has like that weird, one of the textbook ones?
normally they'll ask you to do one thing.
Yeah.
They'll say, here's your function, graph its inverse, which we haven't talked about yet, but we will. That's fine, because that's part of the instructions. But they say graph these. Don't put number 11, 15, 17, 19, 28, but put them all on one graph. Holy shit. Okay. So why do I say that? Because people have done it. So don't do it. Okay. So, let me give you this. We'll do these together, and then I have a, I could have given this to you earlier, but I suck. Because I don't think I gave these to you. Because I'm allowed out there, so I must not have. I don't know why I've done this. So weird.
It changes.
Yeah,
It's like every.
I tell you. I always thought it'd be kind of neat to go to Hogwarts, but no. You guys are scrunched in here. These guys have tons of room. Look at these guys. Bastards. You guys get some of it. May not get one. Okay. All right, here. Let's do this together real quick. On this first one, what's the transformation?
To the left too.
Careful. Left 2, yeah. But it's inside with the variable, it's the opposite. Why does that make sense? Because now every input can be 2 less than they used to be. Because the first thing I'm doing is give them 2. Did I talk to you about the mugger outside the bar?
Yeah.
So if you're gonna go to a bar, there's a cover charge of $2.
You bring in that.
But you know there's somebody out front. This is the reverse mugger. This is the guy that won the lottery. So it's just giving $2 to everybody as they walk past them. How much money do I have to bring to get into the bar? 0. 2 less than I used to have to. Yes? So that's going to be left 2 because all my inputs can be 2 less than they used to be. So what's my base function going to look like? What's the base function?
Parabola.
Yeah, because how do you get the base function? You just take the transformation out. So this would be just x squared, yes? So 0 squared is 0, 1 squared is 1, negative 1 squared is 1. And then you make it curvy because it's squared, so it's not going to be linear. And now how does every point go? Take a point. Where's it go? 1, 2. Take a point. 1, 2. Take a point. 1, 2. Bodacious. How do you check yourself? Check yourself. What's that furthest point? What point is this? What point is that? Point has 2 parts. What point is this? What point is this? No, what's happening? 1, 2, 3, negative 3, 1. Yes? Is everybody with me? I went back there and go up one. So how do I check that that point is where it should be? What do I plug into my equation? What's the input at that point? Which variable is inputs? X. So what's my input at this point? Negative 3. What do I get when I plug in negative 3 and negative 3 plus 2 is? Negative 1 squared is? 1. Hey, sweet. So 99% chance that I'm right. Which is way better than normal, so I'm happy. You could also plug in your calculator, but who cares about that shit? How many transformations here? 2. What are they? Say it again, sorry. Right 1. Down 3. PEMDAS. You still follow PEMDAS in order to figure out which transformations to do when. This specific problem, it doesn't matter, but in general it does. What's my base function? What's my base? Take away the transformation, literally just cover them, and what's my base function? Square root of x. What does it look like? What points does the square root of x go through? 0, 0, 1, 1, 4, 2. Dotted line, because it's not my answer. Jeff, 4, 2, 2. Good job, buddy.
Yeah.
That's why it's good to number your scale first. So I'm going to go, how am I going to move every point? Right 1. 1, 2, 3. Right 1. 1, 2, 3. Right 1. 1, 2, 3. Yeah. And then again, it doesn't matter what point I pick. This is the point 2, negative 2. 2 minus 1 is 1. Square root of 1 is 1 minus 3 is negative 2. Check. Good shit to know, yes? And again, just to let you know, this is the most basic reason why we have to understand shifts. It's just to make it a little quicker to graph other functions. Just start with what it looks like and then move them. That's beautiful. There's so much more that goes with shifting stuff around. Going a little fast, but oh well, too bad. What about number 3? What's the base function?
Square root of 5.
Okay.
And what does that look like? Yeah! Alright, so 0, 0, 1, 1, negative 1, 1. And now it's a first power, so I know it's straight lines. Pretend like those are straight lines, okay. How many transformations are happening? 3. Can you tell me what they are in the right order? What's the first transformation we should do?
Left 1.
Left 1. Somebody else tell me the second transformation I should do.
Up to.
No, that's the last I should do. PEMDAS. Addition is at the ass end of PEMDAS, yes? What's the next transformation I should do? Reflection. Yeah, so you're right. Flip, you can say flip is fine even. Flip around what? Yes, flip around the x-axis. Kick ass. Because it'll be up and down because it's outside, yes? Flip around the x-axis. Or you can say reflect around the x-axis, either way. And now what's the last one I do? Up to. Does everybody understand? There's a whole other reason you have to know PEMDAS. Right? Please excuse my dumbass son. You have to know it. There's a whole other reason why. If you don't like that saying, then please excuse my deficient algebra skills. That'll work too. Did I tell you about that one? Just so you know, I didn't make it up. My class made it up a few semesters ago. You got the deer on Sally. Who cares about it? Is everybody with me? You guys see? Isn't everything we've done a different function? I really need you to see this. I don't give a shit what the function is. The transformations don't change. If there's a -1 next to the x, I don't give a shit what it's in. It's going to go right 1. That's beautiful. So I've got my points. Let me pick a point, and then how do I move it? What's the first thing I do? I was very good for myself. I wrote them. Left 1. Flip around the x-axis. Yes? You with me? I need you with me. So left 1, reflect up 2. Yes? Take this one. Left 1, reflect up 2. Take this one. Left 1, reflect, doesn't go anywhere. It's on the mirror, yes? Up 2. So now it looks like this. Why does it make sense it opens down? Because there's a negative in front. So it's going to open down. How do I check myself? Well, Jeff, you pick a frickin' point and shove it in there. Yes, that's true. So I see -2 and 1. If I plug a -2 in, -2 plus 1 is -1 absolute value, -1 is 1, but the negative is -1 plus 2 is 1. Oh my god. Just do it. Just pick a point, plug it in, see if it works. It's got to work if it's true.
Can you do the reflection part again?
Sure. Okay, so let me take this point here. Yes? I'm going to move it left 1, in fact, let me do this. Let me take a point that's further up here. Maybe it's easier to see. You ready? You guys, I can put as many points, you can put as many points as you want to, but you really only need like 3. So if I take this point here, I'm going to move left 1. Now I'm going to reflect, so I'm going to move it right here, yes? Where's the reflection if the x-axis is the mirror? How far am I away currently from the mirror? 4. So then it's going to reflect to -4. That's the reflection of this, yes? So left 1, reflect up 2.
Okay,
Where's that, Jeff? That is 3 -2, okay. Blah, blah, blah. But let's do these now. So left 1, reflect up 2. Left 1, reflect up 2. Left 1, reflect up 2. Why are you down there? Oh yeah, that's right. This guy. Now see. Yay! So you only have to do 3 points. In fact, I kind of don't want you to do too many points, because then you're sort of making the graph from an XY table. I don't want that. Just want a few base, like 3 base points, move them, redo the graph, you're done. If you're really paying attention, this is too nice to believe. This really isn't that horrible. I think the worst part is, and even this is not that bad, memorizing all the shapes. You should have a lot of these already in your head. You just have to know the general shape. Okay. What about number 4? What are the transformations here? Flip how?
Vertically.
Y-axis. Left and right, yes, because it's in with the X. So if I go left and right, that's flipping around the Y-axis, yes? What's the second thing I do?
Stretch by 2.
Stretch vertically by 2. And what's the last thing I do?
Down 4.
Down 4. Oh my God, yes.
Do you want us to write down those steps?
Hell yeah.
Yeah, okay.
Hell yeah. Because there's 2 levels of thing I have to grade you on. Can you get the transformations from the function I give you? Can you appropriately use those transformations to create a new graph? So I have to see both parts so I can grade you on both parts. If you don't write these down and the graph looks great, I'm like, did you just get that from a graphing calculator? I don't know. That's the other part of that. What's the base function here?
Square x.
So it'll be 0, 0, 1, 1, 4, 2. So if I take a point, I'm going to flip it around the y-axis so that doesn't go anywhere. Is that cool? Because it's on the mirror. Then I'm going to stretch it vertically by 2. It stays at 0, right? Double it. Another way we can say this, double it, but double 0, 0. And then I'm going to go down 4. So this just goes down 4. Because these first 2 actually didn't do anything to it. 1, 2, 3, 4. This point. Flip it around the y-axis. Bam. Stretch it by a factor of 2. Bam. Down 4. 1, 2, 3, 4. Let me do that again. This point. Right there, yes? Flip it around the y-axis. So now I'm here, yes? Is that cool? Now I'm here. Right there, yes? Stretch vertically by a factor of 2. Multiply by 2. Bam. Down 4. 1, 2, 3, 4. That point. Reflect it. Multiply by 2. Stretch it by a factor of 2. And then go down 4. This point. First thing I do is what? Flip it across the y-axis. Stretch by a factor of 2. Down 4. I'll do it again. Reflect it. Factor of 2 up. Down 4. So now it looks like this business. Stretched, reflected, moved down. All that stuff happened to this poor guy. Oh my God, kids, how do you check yourself? No way. So it goes through like -4, 0. So -4, 0, yes? What's -4? +4, square root of 4 is? 2 times 2 is? -4 is? 0! Kick ass! The output is 0 when the input is 4. Sweet. 99% chance we're right. That's so good for me. It's so much better than normal for me. It's not only good for government work, it's suspicious for government work, but that's okay. All right. How much time do I have? I'm not sure if I'm going to make it to the next, to the other worksheet. It'll be all right, because there's another idea I want to talk about. Yeah, okay. So, how do you guys feeling about that? Not too bad. Not too bad. It does suck a little bit that by my x plus 2 I actually go back to, but you just have to, it's not so much memorization, it's just why do I do that? If I'm going to give 2 to my inputs, they can be 2 less than they used to be. Then it's not memorization, it's just doing what makes sense. Okay. So what we're about to get into, the last thing we're going to talk about today, when I say inverse, what comes to mind? Do it again. Opposite, kick ass. Anything else comes to mind when I say inverse? Well, if I say inverse function? Well, inverse. What's the inverse of 2?
-2.
That's one answer. What's another way to say the inverse of 2?
Half.
1/2. One is an additive inverse, the other one's a multiplicative inverse. So inverse does mean opposite. When I just give you a number, it's sort of the opposite operation in a sense, right? But if I say inverse function, what I really want, let's talk about what I want. I will tell you what I want. No, Jeff, don't do it. What I really, really would like. Okay. So let's do the most basic example. What I really want an inverse function to do is to undo what the original function did. It literally should be the opposite function. That doesn't mean flip it, it doesn't mean change the sign. I literally want it to undo what the original function did. So what do I get when I plug a 2 into this? We call this f of x. What's f of 2? Holy shit. Now, so I want the inverse function to have 3 as an input and 2 as an output. You guys, that's the general thing I want to have. Whatever the original function did, I want the inverse function to undo, because it is the opposite function. So the inverse function is not 1 over x plus 1, because that would be 1/3, not 2, if I plug a 3 into it. The inverse function is not negative x minus 1. That won't give me a 2 when I plug a 3 in. So on another level, so that's what I want an inverse function to do. For this specific one, what is the opposite function of adding 1? Yeah, so on this stupid example, I don't need this weird extra layer of business. Instead of adding 1, I want to subtract it. So the symbol we give this function is a very unfortunate symbol. This is a really bad choice. And there are several times in history when I think mathematicians of old were either inebriated or on some kind of substance. So the day they talked about this, they really did a piss poor job. When you see a -1 power, I don't blame you if you think a flip, because that's what a -1 power is. This is not a -1 power. This is a symbol. It means the inverse of f. It means the opposite of f. Does this f inverse do the opposite thing that did? That one added 1, this one. So very obviously, if I take, so what is f inverse of 3?
3 minus
Yes? There it is. So didn't it turn this around? Didn't the original function take 2 and make it become 3? Didn't the inverse take 3 and make it go back to 2? It undid what the first function did. You guys, in fact, let me go one step further. This function, the way it's written, what was the input, what was the output?
Input was 2 and output.
No. This function, the way it's written right now, what was the input, what was the output? X is the input,
And then plus one.
and X plus 1 is the output. You guys with me? You guys with me? How do you always tell what the input for a function was? You just look inside of it. So every function you've ever seen before you ditch it to it has X as an input. Well, sometimes they have T for time, but the inside is the input. Okay. So the inverse function should take X plus 1 and bring it back to X, yes? In fact, in general, if I take this function and I shove it into the inverse, this should undo what this did to this poor guy. The answer should just be X. The way that this took 2 and made it 3, this took 3 and undid what this guy did. What number should that work for? Every possible input for this should work that way, if it's truly the inverse function. So let's see, let's shove it in there. What's f inverse of x?
X minus 1.
So what's f inverse of x plus 1?
X minus 1.
Just to remind you, f inverse of x is x minus 1. So what is f inverse of x plus 1? What do I do with this?
X minus.
Shove it in, yes? I need you guys with me. How do I do this? I take this and I put it into this function. So I'm going to take this and I'm going to put it into this function, yes? I just replaced that with x plus 1. And what is x plus 1 minus 1? X. So I took f inverse and I took f of x and I shoved it in. What should these two do?
Cancel.
They should cancel and I should get x. Did I? Yes. So that is actually proof that those two functions are inverses. If I take one and put it into the other one, they undo each other and I just get x back. That's what I started with. Poor little x dude was wandering around. I grabbed him and I shoved him into a function and shit happened to him. F inverse is somebody come on, I'm sorry man, undo, now go on your way. And the little dude's like, got an alien, the aliens took him. All right, look here. So two functions, two inverse functions, a function and its inverse should annihilate each other, should kill each other. And we know this shit. How do you guys solve this equation? Try to be a cube root there. Cube root of x equals 2. What do you do to solve that?
Cube both sides.
Apply the inverse function, yes. That's exactly what you just said. If I apply the inverse function, they undo each other. Sure enough, what do I do now? Why did we do that? Because what can I do now? I can cancel it. So what we just did was, this was sitting there, we apply the inverse function, these die. And I'm just left with x, yes? If I do that to both sides, I get my answer, yay! So you can't solve a damn thing in the universe without knowing the idea of inverse. So, it's a little important. Yes, sir.
Is it similar to replacing x with y? And
That's
y with
exactly
x?
it. You're so funny. I planted you. So the big thing that I was literally about to say, which is great. No, this is beautiful. Get out of here. Who are you? This went through the point 2, 3. What point does this go through?
3.
3, 2. Do you see it? So the inverse function, I need you to understand this. The original function has an input, x, and it outputs y. The inverse has an input of y, and it outputs x. So they do literally just switch the x and y. Yes, sir.
So if it's f of negative, like the inverse of, like, let's say 7, we just put 7 minus 1.
Oh yeah, sure. If I just said what's f inverse of 7, you would just say 7 minus 1. This is a function, yes? This is just a function. This is just a function. What does it happen to be also? It happens to be the inverse of that function. So a lot of functions we've looked at are inverses of other functions. We just didn't have to look at them that way. Maybe? Love you guys. Yes?
So for the inverses, they only flip the signs, but it doesn't flip like whether the
It
value
doesn't
of,
flip anything about the signs.
like how it's like x minus 1. How is x
Oh! No, careful. What was the operation in the original function?
plus
Add 1. What's the inverse of that operation? Subtract 1.
okay.
So really quickly, if my function was, just to give you a few that you don't even have to think about that much. If my function was 7 times x, what's the inverse function?
1/7x?
Yeah, x divided by 7 or 1/7 x. Yes? If the original function multiplied by 7, what's the inverse function do? Divides by 7. They would undo each other, correct? So it has nothing to do with plus or minus.
So just
Unless plus is the operation, like add and subtract, that's what it has to do with. Multiply, divide, that's what it has to do with. So what if I have a function that has a lot of shit going on?
Inverse by PEMDAS.
Now there's two things going on here. Why does this have an inverse? So let me just ask you this really quickly. If I told you that I squared something and I got 9, can you tell me exactly what I squared?
3.
Nope, you're wrong. All of you are wrong. Good try.
Negative
Next.
3 and 3.
See? So, I need you with me. Inverse is all about working your way back. I kind of look at it like detective work. I need you to understand. An inverse function takes what the output was and brings it back to the input. Yes? You with me? If my function was x squared, it does not have an inverse. Because if I square something in 16, I don't know if it was 4 or negative 4. So if I'm a detective and I see 16, I'm like, oh shit, it could have been 4 or negative 4. Let's get them downtown and have to ask more questions. I can't solve that murder mystery in one go, right? But what did I cube to get 8?
2.
2. Only 2. You with me? Ain't nothing else in the whole universe you can cube and get 8. There are 8. Well, okay, I gotta be careful. There is. There's no real number in the whole universe you can cube besides 2 and get 8. You guys with me? Therefore, cube has an inverse. You agree? Now, real quick, would you guys say the inverse of squaring is square rooting? Would you say that's the opposite? And roughly you would be right. The only problem is, here's what a parabola looks like, and a square root looks like that, except the bottom half fell off. Because it can't go negative, yes? So officially, mathematically, technically, the square has no inverse. I have to actually kill half of its domain in order for it to have an inverse. So what's happening behind the scenes is this. Here's y equals x squared. Why does it not have an inverse? Because how do I get an output of 9? It could have come from here or here, yes? So here's the shortcut. Vertical line test tells me if a thing is a function. Horizontal line test tells me if it's got an inverse. If it doesn't pass the horizontal line test, I'm going to show you, when we get to the graphical interpretation, I'll show you a whole other reason why it's a horizontal line test now. But hopefully this makes sense just mathematically right now. If I have one output that came from 2 different inputs, I can't go backwards. I don't know where 9 came from. It could have come from 3 or negative 3. So, but what's a cube look like? You guys know what a cube looks like? And don't tell me it's a 3, Jeff. It looks like a parabola where this half fell out, yes? Just fell over, I should say. You with me? And that's a little too straight, but that's okay. Does that one pass the horizontal line test? Yes, any output came from only one input. So to be a function, every input can have only one output. To have an inverse, every output can have only one input. And this is why we call them one-to-one. One input for one output for one input. We call it one-to-one, which is actually, for math people, a pretty good name. One-to-one. One input for one output for one input. So this one is definitely a function, yes? Every input has only one output. Does every output have only one input? No! 9 has 2 inputs. Then get it as an output. Okay. I love you guys. So back to this. I know this has an inverse. In fact, I know the inverse is cubed, but how do I do this? Well, first thing I do is I bring y back. Function notation just took the place of y. Now, what did you guys tell me earlier? What fundamentally, just a minute ago you said this, what does an inverse function do to x and y?
It flips them.
Switches them, right? So this is almost too nice to believe. Graphically and algebraically, if I want the inverse, I just switch the x and y. I literally just reach in and switch them. What do I mean? I'm weird. I always have to put a dotted line here because I'm about to do something that's not algebraic. I'm applying an idea. I'm going to just literally switch the x and y. Do you see that? Can you solve for y now? Even if you don't get what I just did, even though we talked about it earlier, it's okay. It almost doesn't matter, because what's the whole idea of an inverse function? All the operations for the inverse function have to be the opposite, yes? So this one adds 1, the inverse better subtract 1. This one multiplies by 2, the inverse better divide by 2. This one subtracts 5, the inverse better add by 5. This one has a cube root, the inverse better have a cube. So even if you don't know why the shit I just switched the x and y, what happens when I start to solve for y? Don't I start doing all the opposite operations to solve for y? Isn't that what the inverse function is supposed to be? What's the first step to solve for y? Yes, my y is in this term. I get rid of this dumb thing. Now what? What's my y stuck inside of?
Okay.
Stupid cube root, so what do I do to both sides?
Cube.
Dear God, don't multiply this shit out. Yes?
You
Did
subtracted
minus
x
x.
from the left side.
I did, didn't I? Oh, okay. We're okay. I'm trying to rush, I'm sorry.
You're adding 1 now.
What am I adding? 1? What?
Because you have 2 subtraction signs.
I love you. Okay. Now I cube, that just kills the cube root. Is that cool? Okay. And then what's the next step?
Add 5.
Add 5. And then the last step,
Divide by 2.
divide by 2. So I get y is x minus 1 cubed plus 5 divided by 2. This one subtracted 5, this one adds 5, this one cube rooted, this one cubes, this one added 1, this one subtracts 1, this is multiplied by 2, this is that, divided by 2, blah, 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 blah. Now, if you think you could skip all this, I highly recommend you don't, because I know we can all see this should divide by 2, but when should it divide by 2? It's in the process of solving this that all of them go in the right place. They all go in the right order. But at least visually, you can very quickly tell it makes sense. And what symbol do I use for this now?
G of negative 1.
Yes, G inverse.
So essentially, another way of solving this is just try to solve for y. If you don't like the inverse.
Yes, switch x and y, solve for y. And in the process of that, you're going to do all the opposite stuff that were there to begin with. So even if for some reason you don't understand why I switch x and y, you actually, and it makes sense why I switch x and y, because in the process of solving for y now, I'm going to do all the opposite shit, which is exactly what I want. Yes, G inverse, yes. So in the middle of the work, I'm going to have y, because I don't want to be messing with G of x. But at the end, I better bring it back to what it is. Yeah. All right, I think that's plenty. So next time we'll finish up inverses. I got a little group worksheet we'll do. Next time is tomorrow. So I'll see y'all in this. If anybody didn't get their test back, come on up here. Yes.
Did we get to 3.6 today?
3.6 and, yeah, 3.7. 3.6 is absolute value functions, which we did very quickly. And 3.7 is inverses.
Okay.
Yeah. Oh, what's your name?
Claire?
Doherty?
Yeah.
Yes.